take from the session is that machine learning by itself is not very difficult. Okay, machine learning by itself is not very difficult, but the idea, if it sticks to you and you supposedly like machine learning, then you are in for a big time gain, because the whole idea of machine learning is changing the way businesses are operating every day. Okay, so what we'll do is I'll walk you through a simple idea of machine learning, and at the same time, considering a lot of us don't have any working knowledge in Python, so I'll show you a code in Python, but I would rather ask you to focus on the takeaways rather than focusing on the syntax. So are we all geared up to start with machine learning? So 60 minutes is what we are really interested in. So are we all ready? Then we can start our session for today. Okay, awesome. So keep this energy flowing and make sure, I really appreciate that all of you are up so late and on a weekday, especially later in the week and pretty late in the night. I assume a lot of you are coming back from office and it might be all the more difficult, but yes, I'm extremely glad that all of you are with me today. Okay, so let's start with the simple idea of machine learning. Okay, and obviously I'll make it a little more easier for all of you, because I know a lot of you are not from a programming background. So I'll ensure that whatever I cover in the session, whatever code, even if I cover a part of code, I'll explain you in the most layman way possible. Please be with me on the idea of the session rather than focusing on the syntax or the tools that we are using. Okay, so stick with me on the idea. Rest things will fall into place. Just to ensure that you all see the things at work. Just theory doesn't really help. We'll also put it to work. And what we'll do is we'll do a small practical case study, which is on predicting wine quality. And with what we learn in the session, you can actually relate what we actually do with the wine quality data. Okay, and then you'll see that how machine learning can really solve a business problem. Okay, so the agenda is going to be pretty straightforward. I'll keep it minimal, and we're going to cover first what is machine learning in a very layman's term. Then we'll follow. It'll be followed by the three types of machine learning that usually the real world sees, and then we'll see the first model that we're going to use today, which is actually linear regression. It's a very popular model in the machine learning world, which will help us in our case study also. What is linear regression all about? And finally, we'll come to the part where we'll see how do you understand if a model is good or bad. So what I'll do is throughout the session, I'll try to make it as simple and as layman as possible. So I'll take it step by step and very layman. For the folks who actually understand machine learning, do not worry. You can just stick with us throughout the session. Also, if you don't understand coding, don't worry. Just stick with us. See what it means and what happens in this world of machine learning. Things will fall into place for all of you. Okay. So Purushottam says machine learning means machine learns itself without explicitly coding to generate human knowledge. Not truly, Purushottam. I think that's a very, I would say, uh, it's not the right definition that you've put forward, but something, it tries to achieve something on those lines. It is nowhere close to what you have answered, but it tries to achieve that. And that is where we are trying to head to. Not even optimization. Okay. Those are all parts of it. Okay. So first, let us understand in the most simplistic way, what is machine learning? So let's just take it a step back and think about how humans learn. Okay. So if I were to ask you, in your school days, okay, in your school days, you had a teacher, right? You had a teacher and lots of students. Now, how does a student learn? So what we're going to do is we're going to take it step by step, and we're going to figure out how do we draw an analogy between the way humans learn and the way machines learn. Okay. So first, so you have a teacher, and suppose the teacher is teaching you a topic called as addition. Okay, so the teacher is trying to teach you a topic called as addition. So 2 plus 2, 3 plus 4, 6 plus 4, 4 plus 5. Okay, now, so what is the teacher trying to do when she's showing you this kind of information? The teacher is trying to explain to you that if you have two numbers at hand and then you see a certain symbol, okay, it's a pattern, right? A certain symbol that you're seeing, these two numbers, you can keep it side by side and you can count the total output, which is 4. So the teacher is trying to train you. The teacher is trying to train you and make you understand that when you have two numbers with a symbol in between that looks somewhat like this, what are you trying to do? You're trying to club up all of these numbers together, which is the final output. Now, obviously, during teaching, I hope all of you agree to this point that I have to show the input as well as output. Would you all agree to this point that I have to show the input, which is these two numbers, as well as the output? Would you all agree with me on this point? Right? During your training period, when the teacher is trying to make you understand what exactly is addition and how do you do it, so the teacher shows you the set of inputs and tries to explain you how does it relate back to the output. Now, this is good enough for you to learn the idea. But once you get the idea, what do you do next? How does the teacher know if you have learned it properly or not? So the teacher has trained you, but the teacher needs to also check that if you have learned it properly or not. How do you think the teacher is going to check it? Absolutely, an exam. Okay, test or an exam. That's pretty straightforward, right? If the teacher has trained you, the teacher also needs to evaluate if you have learned properly or not. So what are you doing? You are giving an exam or a test. Now my question is, in the test, do you expect the teacher to give you the input as well as the output, or only the inputs? Pretty obvious, right? Only the inputs. Because you are going to give me some output, and how will the teacher evaluate the output? How is the teacher going to evaluate the output? The teacher already has the answer key, right? Would we agree on this point that the teacher already had the answer key? And based on your answer and matching with her answer key, the teacher is going to evaluate your score. So how does the teacher really differentiate between student 1 performance and student 2 performance? How does she evaluate between student 1 performance and student 2 performance? Based on the score, absolutely. Okay, so the score or the marks that the student gets based on that. Okay, so PM, don't worry, others need to change it, but even if you don't see, I would really appreciate if you also participate and try to answer the queries rather than waiting for others to answer the queries. Okay, so feel free to address it. There's nothing called as right or wrong. Just give it an attempt. I know everything might not be very easy for all of you right now, but the more you start participating in this field, you'll trust me, it's going to be the more interesting. Okay, so this is how humans learn. Okay, any doubts with the way humans learn and the way we find the best person? Any doubts or any queries? Okay, yeah. Now, this is what we have drawn from humans' way of learning into machines' way of learning. Okay, we have drawn humans' way of learning into machines' way of learning. So Nikhil or Vishal, if you can help Vedant. Vedant is having certain problems with the audio. Okay, for the rest of the folks, let's focus back on our way of machines learning. So let's take one more simple example. Now, this is how humans and machines learn. So humans, I saw that I had to train the humans and then I had to test the humans. Based on the test, I knew if the human actually understood this concept. In the test, I might ask the human, what is 10 plus 10? Okay, and the human is supposed to answer this question and I will evaluate with the known result. If the person is good, okay, suppose student 1 has scored 98 and student 2 has got 96. So say a company hires student 1. The company will hire student 1 because student 1 is clearly better than student 2. Now, what will the student 1 do in future in the company? In the company, we know that student 1 is capable enough of doing addition problems. So the company will give student 1 new problems, okay? Something like 22 plus 44. Maybe the student has not seen this, but knowing the pattern, the student can easily find 66 because I have faith that the student is good in addition based on its performance in the test. Okay, would you all agree to this point that based on the performance of the student in the test, this student would also predict in future pretty well because the student was good in addition. Okay, now let's move to the machines part. Now, what you saw as a pattern, so 2 plus 2, what you saw as a pattern here, how difficult do you think is this to understand? How difficult is this pattern to understand? So even if I, instead of writing 2 plus 2 to a kid, I can say that this is an apple, this is one more apple, this is one more apple, this is one more apple. If you do addition, how many apples do you have in all? So you have 4 apples. So the answer is 4. So would you agree that it is not very difficult for humans to understand this idea? Yes? Even if I like increased it to 6 plus 6, I could have drawn and explained to a human. 6 plus 6 is 12. True? So we all agree to this point that this is rather a very easy problem for humans to understand. Let's think about a little different idea. The price of a used car. Could anybody help me understand what are the parameters? If you guys have bought a car, you would know this idea. On what parameters do you really price an used car? So if you're going to buy a second-hand car, what are the things that you're going to really be bothered about? The year, the model, the company that manufactured the car, the make, okay, maybe the horsepower, mileage, okay, and maybe another set of 100 such parameters. And say the last one being say color, okay, suppose the color of the car. Now suppose you have even, I forget about hundreds of parameters, say you have just 7 parameters, 1 2 3 4 5 6, yeah, 6 parameters. If I give you a list of 6 parameters, I give you say a data of 1 million such cars with these 6 parameters, and I tell you in the history, these 1 million cars were sold at so and so price. So one of the cars was say Maruti 800 sold at 40,000. There was a Ford Figo sold at 2.4 lakhs. There was some other Esteem which was sold at 1.2 lakhs. So likewise, I give you data of 1 million such items. My question to you is, would it be possible you as a human to find a pattern between these 6 parameters and the price, such that if you trained yourself on this data and then I were to take a test and give you six new parameters rather, and you would be able to predict what is the price of the new car, or rather the next used car? Would it be remotely possible for humans to find this pattern? Absolutely not. All of you are absolutely correct that a human by himself is not capable of digging into so much volume of data and so complex data. Finding this pattern. So if I say if I just replace if I replace plus with say a new symbol, okay, suppose I replace it with some new symbol, something that looks like this, okay, and I say this is 4. Then I do 3 plus 3. Okay, the same symbol I repeat, that is 6. You can identify that this is basically addition. Okay, even if I hide this symbol and say that there's some kind of pattern that exists in both the statements, can you tell me what is the pattern? You can say yes, they're just addition. They're very simple addition. So identifying patterns in some smaller things is not so difficult for humans, but once it becomes really complex, which is more like real world, it becomes exponentially difficult. How do I predict the price of a used car? Now I know these are the parameters, but based on these parameters, can I automate my way of calculating prices? Let's see one real world example. A lot of you might feel that, okay, Suchit, till here, it looks like you're talking two different things. One is a very easy topic and one is a very difficult topic. But let's see it in action. Let's see it in practice. Okay, I'll show you. Let me share you my screen and I'll show you one of the ways in which all of you may have witnessed this. You may have witnessed this. Help me understand if you have seen this website anytime. How many of you have visited this website or seen this website? And what does it do? What do you do on this website, friends? Absolutely, you sell used cars, right? Yeah, you get the price of your used car, right? But how does Cast24 tell you the price of your used car? How does Price24 know what is the price of a used car? And I'll just show you how does it work. So you see, they're asking you what is the make of the car. Okay, so is it a Honda? Is it Tata? What is the model? So let's say it's an Amaze, which is the year, say 2014, which variant, let's say SAT, AP, 20 to 40,000 kilometer. You can give your phone number and email ID. And then what does it do? It tries to give you a tentative price. You see, it gives you a rough price, a tentative price. But how does it even land up to a tentative price? How does this website understand the tentative price? The idea behind this is all machine learning. Suppose we did not have machine learning in real world. How do you think somebody would have got the price of the car? Suppose we did not have machine learning in real world. How do you think somebody would have got a price of a used car? Manually checking other prices, absolutely. Very good, Himesh. Historically, selling price. So if it's a Maruti 800, I'll see how much did I charge for a similar kind of Maruti 800 for the last 2 years. Okay. I would see, yeah, I would rather focus on the engine quality, the feel of the car. Okay, I had to do a lot of things manually. But then is manual the best way to solve your day-to-day problems? Do we solve day-to-day problems manually? No. I would any day prefer automated solutions. Why? Because machines know how to find patterns on larger amount of data. As humans, I can probably see all the Maruti 800s for the last 2 years. Okay, that's totally okay. But are we only selling Maruti? We are selling Honda, we are selling this, we are selling that. There's so many different varieties of car. Within Maruti, there's so many different sub-brands. Within the sub-brand, there's so many variants. Within those variants, there's so many other features. Can humans possibly find all the possible patterns for so many varieties? Not at all possible. So how does Cast24 really succeed? They succeed because they are using machine learning. Machines are very good at finding patterns in large amount of data. Instead of relying on humans to suggest a price, okay, when a human is suggesting a price, the biggest challenge is there could be some biasness in the human. Okay, why don't we trust an agent? Why don't we trust an agent? So think through. I need all of you to think through and tell me, why do you think we don't trust an agent? What is the bias that the agent is always holding? Yes, greed. Okay, profit. The agent is more interested in his or her profit. And that is why we are not interested in agents. We would rather want something more scientific. And what could be more scientific than study of historical prices and landing up on a value which is calculated using the historical behavior? But to find that historical behavior, millions and millions of records have been studied thoroughly. Cast24 has studied millions of such records thoroughly. So when a company like Cast24 is studying all of these records thoroughly, obviously it is not doing manually. It is being done by machines. So this is where machine learning comes into play, a very important aspect that I want all of you to carry today. So the idea of machine learning is helping machines learn from historical data and letting them find patterns such that once it is trained enough, I can check if it is working properly by a small test that I can do, for which I already know the questions or the inputs as well as the output. I will not show the output. I will only show the input and ask the machine, what is your call? What is your call? If the machine gives whatever answer the machine gives and whatever answer you held, which is your answer key, you have to compare and check if the machine is able to predict properly. And once you're convinced that the machine is able to predict properly, what do? You deploy it in real world. Something like Cast24 that we saw here. Make sense, everybody? That this is a simple analogy drawn from humans' way of behaving or humans' way of working, right? So this is where machine learning is all about. Okay, this is what machine learning is all about. And obviously the journey is not something that can be done in a small span of time, something that takes a little learning, but let's go through it at a very high level. Suppose we just want to understand what it is all about. Okay, so the idea of machine learning was to ensure that we move out the logic aspect. Okay, we move out the logic aspect into the computer. Initially, I used to find the logic. I used to try to find the relation between the car manufacturer, the the car model, or the car other properties of the car. I was one who was more interested to figure that out. But today, I want the machines to do that, because it's a very complex relation, and I, as a human, I'm not well versed with it. I am not capable of sorting out such enormous challenges. So that is where machine learning actually truly flourished. Now let us do one thing. Let me just clean up the screen. So there are different types of machine learning, primarily three types, and today we are going to do one of the type, which is called as regression. So if you see here, so there are two types, supervised and unsupervised. Supervised is where you have inputs and outputs. You have inputs and outputs. So I know my inputs, I know my outputs, and I'm asking the machine to find patterns. So the Cast24 example, what kind of machine learning would it be? Yes, it'll be supervised. Why? Because I had certain inputs and I had certain outputs, and it tried to match the input to output and learn. It tried to learn the patterns. Now within supervised, we have to understand there are two types, classification and regression. So we'll not dig too deep into both of these, but let's put it in a very simple way. If you are finding continuous variables, okay, if you're finding continuous output, something like price, okay, price is what? Price is, it could be 40,000 or it could be 40,001. How many values can technically exist between 40,000 and 40,001? Technically. Infinite, absolutely. Okay, so you don't know, the price could be 40,000, it could be 40.0000 something, or it could be 41,000.01 of 05 or whatever it could be. It could hold any values. Okay, I'm not saying that it has to match a number of in the terms of denominations of coins, but in terms of technicalities, there could be infinite. So regression is mostly on the numerical side of the story. So when your output is mostly numerical and it does not have a fixed number of output possible, we call it as regression. Classification, on the other hand, is something that is countable. Regression is uncountable, classification is countable. So in classification, something like if you go to a bank for a loan, what are the only possible answers that you might get from the bank? Very good, Anu. Yeah, the answer is yes or no. The only two possible answers is either the bank approves your loan or rejects your loan. Okay. If I have a certain number of say photos, I have certain photos of animals. There can be only fixed number of them. So it can be a cat or a dog or a lion or a cheetah. So that's like fixed number of outputs. So in such cases where the output is mostly textual in nature, or if it's numeric, then it is countable in nature, countable classes. The idea of class, it is countable. So we call it classification. In both the cases, it is supervised classification as well as regression, because we give the machine initially to train, we give the machine both input and output. The machine is supposed to find the patterns between input and output, and then we use this machine to do future prediction. Yes, you have labeled data. That's the technical way of thinking through, Abhishek. Absolutely. Very good. Now, there's one more kind which is called as clustering. Clustering, a lot of you may have heard about clustering in some way or the other. So let me make it a little simpler. What exactly is clustering? Let's think from a kid's perspective, from a very young, I would say an infant. I would say an infant would be the right word. So let's think from an infant's perspective. If I have, say, few fruits, which is something like yellow long fruits, and few green huge fruits, green color round huge fruits, and then I have red color fruits, and then I have orange color fruits. Okay, the kid obviously doesn't know the name of these fruits. Okay, the kid obviously doesn't know the name of the fruits. But what do you think the best that the kid can do with these fruits apart from eating them? So apart from eating them, what do you think the kid might do with these fruits? They are all mixed up. It's a fruit basket that I had. The kid has split. Yeah, the kid has spilled this fruit basket on the floor. What do you think the kid can do at best apart from eating them? Absolutely. Yeah, so think the best case. I'm not asking for the worst case. And the worst could have been the kid could have eaten them or destroyed them or cut them into pieces or tear them apart. What is the best case that you think the kid could have done? Excellent. Most of you are absolutely correct. The kid could have just separated them. Okay, as a kid, even if you remember, if you were playing, you also do used to do the same thing. Used to arrange them into separate groups and keep them separately. Now the question is, how does the kid group them? How do you think the kid is grouping them? Excellent. So by the size, the color, the shape, okay. So here, was the kid really looking at any kind of output? Was the kid trying to find any kind of output here? No. The kid was only trying to group things based on similarity. Absolutely. All of you are absolutely correct. The purpose that the kid was trying to solve here was to group them into different classes together, different groups together. The kid was not interested in the names of the final fruit. Whichever group you group them, the kid has no idea what these yellow fruits mean. Okay, the kid just by look and appearance, the kid group them together. That's it. Why do you think this would be a very important problem to solve in real world, which we also call as clustering? So I'll just make it a little simpler for all of you. Clustering, which is an unsupervised learning, because the input, if you remember, was only the features of the fruit, which color the fruit is, what is the size of the fruit, the shape of the fruit. Nobody was interested in which category does this fruit fall in. Okay, nobody was interested in the category of the fruit. I was only trying to understand how do I group them based on its texture. How does this fit into real world? We call it as clustering, and this is a very popular application in real world. A lot of you may have heard it also. It is called as customer segmentation or market segmentation. It's a very practical use case that almost all of you have either experienced in some way or the other, and some of you actually know it without even understanding. And after that, Abhishek, you're right. This is used for target marketing. Absolutely. So what do companies do? They try to segment their customers. How many of you often get calls for loans? How many of you often get calls for loans? Always, right? Yeah, almost everybody. So anybody who's earning would get a call for loan. Similarly, anybody who's already taken a loan might actually get a call for taking one more loan. How does a bank know whom to call for what? How does the bank know that someone have to call for loan, somebody have to call for credit card? Okay, they have the data, but having the data is not all. They also need to see Should I, so suppose they have everybody's data. Should they actually call everybody and sell their credit card? Okay, there's a premium credit card that they have. Do you think they'll call everybody and tell them that, sir, why don't you take this premium credit card? No, because premium credit card, they only give out to few people. But who are the right set of people? So all of these come through customer segmentation. These are the people who are the CXO level people. These are the people who are the mid developer, mid employee level. These are the low income people. These are the people who deal with a lot of cash. So does it make sense to send credit card to people who actually use cash? No. Rather focus on the CXOs, give them high-end credit cards, because these are the people who spend a lot, but they also have a very good repaying capacity. So the bank needs to know who's the right set of customers to whom give out the to give out the credit cards. So it's as simple as that. The bank was not starting the problem with the idea that, okay, these are the people I'll give credit card or not, but they rather started with segmenting their customers to understand which is that right set of customer to whom I'll give the high value credit card. Okay, so this was the starting point. Give them, whom should I give the high value credit card? I didn't know which category of customer it was. First, I grouped them into their respective groups and figured out this group is the group of the people who earn a lot and they have a high repaying potential. And then I said, right, this is the right group to whom I should send out all the messages regarding high value credit card. Okay, so this unsupervised learning is the second type of learning, which is very popular in the machine learning space. The third one, which is called as reinforcement learning, I haven't used it here because it's a very complex concept to understand right now. But if you understand I believe a lot of you have already heard about self-driving cars. Have you all heard about self-driving cars? Right? So what does a self-driving car do? So when it is on the road, the moment it comes across an obstacle, okay, when it comes across an obstacle, what does the car do? The car takes a decision that, okay, I need to stop. Okay, it needs to brake. Okay, it needs to apply the brake and stop. Or alternately, should it take a roundabout way? If the car is traveling and the car needs to overtake, and there are a lot of cars in front, what does it do? It needs to figure out, should I take a by route and overtake the next car, or should I wait for the car? Should I go slow? Should I go fast? The car has to take a decision at real time. Okay, but this decision that it takes at real time is influenced by its learning in the past. This decision that it takes at real time is influenced by the learning it has achieved in the past. So what happens is this car is trained on a lot of data and it tries to learn by itself. So what happens is this car is exposed to a road. Suppose it's exposed to a road. The car starts from point A to point B. The car is supposed to go from point A to point B. Now, the car can start and go this direction. What will happen if it goes this direction? Say this is the first attempt. So A1, attempt 1. What happens when it takes this direction? After a certain while, what happens? The car goes and hits the wall or hits the side of the road. Was it successful in reaching from point A to point B? Absolutely not. Right? It did not successfully reach point A to point B. So it tries multiple such attempts. Say second attempt, it just readjusted. So it learned that A1 wasn't the best approach and it added some negative reinforcement. What does negative reinforcement make you do? It makes you not take that route again. Okay. Then it goes for second learning, A2. What A2 does is it goes better than A1. Would you agree on this point that if I had followed the A2 approach, the car could have gone a little more deeper, a little more further. Okay, would we all agree on this? Absolutely right. Yes. So what will happen is, I'll say that yes, A2 is also better than A1. My strategy is improving, but I'm still negative. Why? Because I again hit the wall. So A1 strategy built to A2, which is better. Again, you follow the same route, improve the strategy further. And this time, the car was able to traverse from A to B. So the car learns through negative reinforcement that A3 strategy is supposed to be the best strategy. Because in A3, it did not have any kind of negative reinforcement. So on similar line, there are various such use cases that a car needs to get trained on something. So here, this was a simple example, but in real world, is your road going to be as simple as this? No, there are going to be lot many more difficulties, but that's where computers are good at. They can take into consideration tons and tons of permutation combination. What is the technical term used for negative reinforcement? We call it negative reinforcement only, Abhishek. It's a negative reinforcement. So the car actually crashes, that's called as a negative reinforcement. So basically it's a negative value and your strategy is cancelled there. Okay, so the idea of reinforcement learning is the latest idea where tons of research is being done and probably one of the best ways in which deep learning is going to benefit in the long run. What is deep learning? We'll come to all of this towards the end of the session. Okay, so basically our main focus for today is regression, where I am going to give the computer certain input and output to train. What is train? The computer will find patterns between input and output and say that, yes, I'm ready to predict. But should I trust the computer directly? If the computer is just trained, should I trust it directly, or do I need to take one more step? And if I take one more step, what should that step be? Absolutely, I need to test it. Okay, I need to test it if it is capable enough on my known data. Because if it predicts, I don't know, it's future, right? In future, if somebody is predicting, I don't know if it is right or wrong. But I can always have a test set where I know the questions, I have the answer key, but I will not give the answer key. I would rather hold it back and ask you to answer and then compare the answers to see how good was this model. How good was this machine learning product that I built. So I'll be training that system, I'll be testing the system, and then finally, when I'm convinced that the system is good enough, I will ask it to predict future values for which I don't know what could the possible output be. Okay, so this is how machine learning works in real world. A simple idea of how machine learning actually learns. How do they learn patterns? So a lot of you might have this question in mind that, okay, Suchit, you just explained us what is machine learning, where machines are trying to find patterns. So let's try to see how machine learns patterns. Suppose, let me make a very simple example. Suppose I charge $1 for 1 hour and $10 for 10 hours. How many dollars should I charge for 5 hours? For consulting 1 hour, I charge $1. For 10 hours, I charge $10. How many dollars should I charge for 5 hours? So this is hours and this dollar. So this would be $1 and this would be $10. How many for 5 hours? I see a lot of you are writing $5, but on what basis, friends? On what basis? Yes, the concept is that of linear algebra. Y is equal to mx plus c. What is this equation called? Equation of a straight line. Excellent, right? It's called an equation of a straight line. Absolutely. So based on the equation of the straight line, what I understand is from 1 hour to 10 hour, my increment of my amount that I charge is basically a unit dollar for every hour. For every hour, I charge a unit dollar. So 9 hours, a difference of 9 hours, because 10 hours and 1 hour, a difference of 9 hours. How many dollars difference? It is 10 minus 1. So 9. So 9 by 9 is nothing but $1 per hour. And this is exactly the idea that all of you have used. So if it is $1 per hour, you multiply by 5, that will become $5 for 5 hours. Are we all on the same page? Would you all agree to this point? So did you observe that you actually figured out a pattern in the data? Did you observe that you figured out a pattern based on a mathematical idea? And you could actually predict what is the charge that what is the price that I'll charge at 5 hours. Okay, all of you actually found a pattern, a mathematical pattern in the data, and based on that pattern, you could actually predict how much I would have charged for 5 hours. And the answer is $5. All of you are correct. If I just draw this line here, okay, I would have landed up at $5. It would have been $5. How equation line fulfills this pattern? So Prabhat, you have 1 point here, 1 point here. Okay, and I told you 1 hour, 1 hour, $1, 10 hours, $10. Okay. When I asked you how much you charge 5 hours for 5 hours, what you tried to do is you tried to find a pattern between that exists between the 2 points. What is the pattern between 2 points? A straight line. Based on a straight line, what you did, you calculated for 5 hours. As simple as that. Okay. Now, I hope Prabhat, you remember this equation of a straight line from school days. Okay, this is a simple concept. Yeah, that's this very same concept that we are using. Now, my question is, obviously, real world is not so good to you, right? In real world, do you think things are going to be as smooth as this? Definitely not. Okay, in real world, your points are going to be everywhere. Your points are going to be everywhere. Okay, sometime I was in a good mood, I gave somebody a discount. Sometimes I wasn't in a good mood, the client was asking me to do too many things for in 1 hour or 5 hours or 10 hours. I charge enormous amount. Sometimes I charge very low because I was not getting any work, so I gave them hefty discount and I got a work for a very cheap price. So that is how real world is. Real world is not going to be everything on the same line. So if your data is not on the same line, does that mean you are not going to predict in future? Does that mean from this data you can do no kind of prediction? Does it mean I'll stop even predicting how much I should take for 7 hours or 6 hours? Definitely not, right? All of you are correct. We wouldn't stop our work. We would still try to figure out what is the best case. What is the best case? Okay. What could be the best case? The easiest way you can see the best case is find a line somewhere in between. Okay, find a line somewhere in between. Because the idea is very simple. I can't use this green line. Okay, suppose I said, okay, let's kind of drop a random line. Any hours, you calculate the price through this line. Is that a good idea? This green line? How many of you would call the green line as a good idea? No. The blue line also isn't a good idea because all of these points are somewhere else. Your points are somewhere here, but your line is somewhere else. The green line and the blue line is not going to solve your problem. The red line is the only line which is close enough to all the points and makes a scientific guess. If I were to do a random guess, I could have done this, a random guess. I could have done either of them, the blue or the green. But if you do it scientifically, this is what you will always land up to, a place which is somewhere in between all of the points. And this is called as the line of best fit. Any doubts why green line I wouldn't have selected or the blue line I wouldn't have selected, but rather the red line is the best line? Any doubts? Based on this, one question that would be obvious to all of you, but Suchit, aren't you having any kind of error here? You actually are introducing a lot of error because this point is actually not on the line. This point is not on the line. This point is not on the line. This point is not on the line. The question is, you are not exactly right. So my question to all of you, in business, do you give out credit card to only people who can actually repay every month? Do you think it is a good idea to give your credit card to only the people who can repay every month? If you give it to them, you actually make no money on your credit card. Okay, so if you are giving out this credit card to those people, you get no money. So rather, you want to be a little risky. Okay, you want to be a little risky, but you don't want to be a fool. You want to take risk, but you are not a fool. So this is the idea of scientifically deducing a futuristic probable value. Okay, knowing the point that you are not going to be 100% correct. Knowing the point that you're not going to be 100% correct. But just to execute business, I will be scientifically smart. That's the whole point. Find those customers who may pay you on time mostly, but still have certain chances of defaulting. And that's where the money is. Okay, so this is what machine learning tries to achieve. It does not try to achieve 100% accuracy, but it definitely tries to achieve a certain scientific output which can help you make good business. Okay, a simple idea. If I know what is the price of say iron ore, okay, suppose I'm a steel company. If I can predict what is the possible price of iron ore for tomorrow, for next Monday, it'll be so good for me, right? something scientific. I'll try to reduce the price of iron ore for next Monday. Idea would be, I would see based on this regression pattern, what is the price? Maybe say $100 a ton. This idea is a scientifically deduced idea because based on my historical data, I've seen the prices fluctuate in this angle. And for this certain day, for a Monday, I've seen that the price is usually $100 for iron ore. Now, if it is more than my expected value, what do? I can stop beforehand whenever the prices are cheaper. If it is less, I will actually wait till Monday and then buy more. Okay. Now you can go wrong. I'm not saying you can't go wrong. You can go wrong, but most of the times you will be right because you are following a historical pattern. This is what linear regression helps you achieve. Finds one of these lines, which is the best fit line, which represents your data as close as possible. Okay. Obviously, in real world, there are a lot many more complexities, but linear regression solves it in the most easiest way possible. Okay, and not necessarily, obviously, when it's trying to solve in the most easiest way, not necessarily it is going to be the best answer to all your problems. But let's see from a use case perspective, how close can we get to real values. Okay, so whatever linear regression problem that we saw here, I'm going to apply that in our use case today, and we're going to see how close we can get to real value. Keep this in mind. Why not a curved line? Yeah, so Prabhat, that's the whole point. You have to understand, right now I'm only teaching you one of the basic algorithms, which is linear regression. In real world, will I only stick to linear regression? No, I'll move on to the other ones. Okay, I'll try to see better ones. Now, in the next one, let me just walk you through this rough idea of what are the steps that we usually do in machine learning, which we'll see in action. First, you get your data, you collect your data. Then you have to ensure that you clean your data, make it proper. If required, you got to manipulate the data and make it standard. After this, you push this data to the machines. The problem with machines is, does machines have brain? Would you think machines have brain? Absolutely not. So suppose if my machine has a certain bad data, okay? If my machine has a bad data, where the price of Maruti 800, by mistake, somebody has typed it instead of 2 lakhs, they just gave in 2 more zeros. Okay. So instead of 2 lakhs, by mistake, they added 2 more zeros. Is this a right value of Maruti 800? No. Do you think machines will understand this point? Absolutely not. Machines will not understand. So you are the one responsible to ensure that you clean up your data. Okay, you clean up the data, you make it good, you make it accurate with respect to what your business is, and then you give to the machines. Otherwise, the machine will see it as is. Okay, so that is why the second step is the most important step in real world. Machine learning is a very small part of it. The biggest part that any data scientist does is this first 2 points: getting the data, cleaning, preparing, and manipulating. This is called as pre-processing. Pre-processing is the most important step that any data scientist does. After that, we're going to pass it to the machines to learn patterns and see how does the input fit to the output. Finally, we will test it to see if the model is good or bad, if the machine is able to predict properly or not. And at the end of it, once you have done all of these and you have actually started using it in real life, what will you do? Once you have started using it in real life, every day you're going to try to improve it. If you have made your machine learning model once, will you stop improving it in future? No. Every day you have to keep improving it. Okay, so you have to collect more data. You have to see where are you going wrong. Are you passing in bad data? If yes, take out the bad data. Try to make the machines learn again. It's the very same way that humans learn. Which human stops learning? Okay, all of you are in this session for that very same reason, that we all want to learn. Okay, so we never stop learning. We never stop improving. So similarly, machine learning algorithms will never stop improving. Once we have done a certain use case, we'll keep improving on it. So without any further delay, what I'll do is I'll actually show you this wine price prediction. How can I clean data if the data is used? So Prabhat, for that, you need to know coding. Okay, and that's what the entire world is all about. In machine learning, whatever we are doing, it's all in coding. Okay, now before I start with the coding part, I would really want all of you to understand that what I'm going to show in the code, I need you to be wary of one thing. We are not trying to understand the syntax or the packages or what is used in the code. Rather, I want you to relate it back to the PPT that we just saw. In the PPT, we saw a few steps, starting with you collect your data. Second is you might want to clean up. Okay, you want to make the data comprehensible to the machines, but at the same time, it should fit your real world. After that, what do? You apply model, okay, machine learning, where the machine tries to learn what your data is trying to show patterns. And in today's data, we are going to find patterns between features of a wine to the price of a wine. Features of a wine to the price of a wine. Any idea what are the features of a wine that decides the price of a wine? What features of a wine? Age, yeah, it could be color, the odor, there could be multiple such texture, okay, brand, taste, okay, a lot of them. One more information that I need from all of you. If I know the price of a wine is high, what is the obvious conclusion that I draw? If the price of a wine is high, what is the obvious conclusion? It's a good quality wine, absolutely. So do you understand this point that if machines can predict the price of a wine, the best part is nobody actually needs to drink the wine to know if the wine is good or bad. For how many, this is a very vague concept. For how many are you not able to even think of this idea that without even drinking the wine, how can somebody really decide the price of a wine or even the quality of a wine? Isn't it a little difficult to digest? How many of you would say the same? Without even drinking the wine, how can somebody say if the quality of a wine is good or bad? That's really difficult to digest. But friends, that's where machine learning is so popular. That's where machine learning becomes so smart and beautiful. So let me share you my code and I'll walk you through the code one by one, step by step, and then you will see how beautifully our machine can actually predict the price. And if it can predict the price, in effect, what is it trying to predict? It is trying to predict the quality of the wine. So without even drinking a wine, how beautifully machines can tell you how good or bad a wine is. As simple as that. Okay, so friends, these are the standard steps that we usually do in machine learning. It's going to be like very standard. All of you are going to follow the same approach for every kind of problem. But internally, the way you deal with the data, that is going to be different for all of these different data sets and different problems. So first is import required libraries, which means that I will use some ready-made code. Obviously, if I have to be smart in data science, I'm not going to write code entirely by myself. I'm going to use some ready-made codes. So I'll see how I can use others' hard work and solve my business problem. That is what importing library means. Second is I load the data. I have certain data around wine. I will load it and then I will prepare it and see how I can kind of make use of this data. Then I'll push it to the machine to find patterns. Obviously, as humans, I'm not very good at finding complex patterns. When the data is a little complex, as a human, I find it very difficult to find patterns. So I'll push it on the machine to find the patterns. So the pattern that we're going to try to find, input versus output. The input is basically the features of the wine, and output is the price of the wine. So we are going to see how does these features, so say we have 4 or 5 features, how does it relate to the price of the wine? And as humans, I'm not great at it. I would want machines to do it for me. Finally, I'll also check it on a test data to see if my model is good or bad. Then we'll evaluate the model and see which model is good. And finally, if you want, you can go ahead and create more models. Okay, so you can go ahead and create as many models as you want. In real life, we don't stick to one model, we create multiple of these. But today, for simplicity, I'll just use one algorithm to explain you how you could have solved this problem of finding the quality of the wine without even tasting it, without even touching it. If you just had the input data of the wine, you could actually have predicted which wine is good and which is bad just by going through the patterns between the input features as well as the price of the wine. So Anil, this video will be recorded and it'll be uploaded on YouTube also, so you can always refer it back from YouTube. Okay, so friends, first things first. As I told you, the best part about using Python is I don't have to code everything myself. There are people who are experts. I'll use their hard work and I'll solve my problem. I'm more interested in solving my business problem. Okay, so I will use somebody else's hard work and I will solve my problem. So all of these different libraries that you're seeing, these are called as libraries. These have a lot of codes written by experts. I'm not that great as an expert. So what I do, I just use their hard work and I solve my problem. So let us start first with the data. So I have a CSV which has this wine data. Now I want to see what are the wine data. So this is basically the wine data. The wine data has the year of the wine, the winter rainfall, the AGST, the harvest rainfall, the age. AGST is average growing season temperature, the age of the wine, and what was the France population back then. Okay. So if you see here, price is technically dependent on all of them. Would you all agree to this point? Price is technically dependent on the rest of the columns. Year, which year the wine was made, what was the winter rainfall? So the vineyard where the grapes were growing, what was the winter rainfall? What was the average growing season temperature? When the grapes were growing, what was the average temperature? Because based on the temperature, the grapes could be nice and juicy, or they could be dry if there was lack of, if it was like pretty hot back then. Harvest rain, too much of rain spoils the grapes. Okay, and if the grape is spoiled, the wine is also not of great quality. Age, okay, the age of the wine. When was this wine put on sale? So what was the age of the wine at that point of time? And finally, the France population. Why do you think population could also impact price? Why do you think population could also impact the price, friends? Demand and supply. Absolutely. If too many people are looking for the same wine, it means that the demand for this wine is good. And that means people actually prefer this wine. And the prices are going to go high. But somewhere down the line, it could also mean that just because of demand, the prices are high and may not always be implicative of the quality. So we'll see it in action. We'll actually put it to use and understand. Okay, all of these features actually affect price to some extent. Let's see how we can use it. So these are my inputs and outputs. Okay, this is my training data because I have the input and output. But in the test data, am I going to show the output to the to the model? No. Though I have the answer key, I'm not going to show this answer to the model. I'm going to keep it. I'm going to hide it. I'll give the inputs and ask the machine to predict what could the possible value be for this first wine and for the second wine. And then we'll see, is my machine able to predict it good, properly, or not properly? So first is, as a data scientist, I usually do these analysis. Okay, we usually do these analysis to understand how good or how bad a particular data point is. So what are the possible values of year? What are the possible values of price? What are the possible values of winter rainfall, growing season temperature, harvest rain, age, France population? So these are standard steps that anybody would do. Now, if you notice, in the next step, I see that there is a price that is missing. I see there's a price that is missing. Now, what does it mean? If your price is missing, can I use that data point to train the machine? Can I use this data point to train the machine? So suppose it's like in class, the teacher says, okay, friends, I don't know what does 5 plus 12 mean. I don't have this answer with me. Can I use it for training? No, I can't. Okay. So definitely this is a point that I can't use. So you see the data has certain flaws. It has certain problems, certain flaws. When I was analyzing the data, I saw harvest rainfall, age is -7. Can age be -7? No. Okay. So the data has a lot of flaws. It has a lot of problems. Winter rain has -418. How can you have negative rainfall? You cannot have negative rainfall. Okay. So what I do usually in real world is, as a data scientist, we have to pre-process our data. We got to just ensure that we can wrap up and get rid of data that is bad. So you see here beautifully, we can drop any data which has winter rainfall less than 0. We can remove data where the prices are missing. Okay, drop any means not applicable. So empty values, you can drop the data points. So finally, what I land up with is roughly 25 rows of data. I have 25 rows of input data. In this, I have year, winter, rain, AGST, harvest rain, age, and France population as my inputs. And these inputs are going to decide the price of the wine, which is the output. All of these input together will help me decide the price of the wine, which is the output. So I'm interested to find all the features, okay, all the features of the wine, and how do they impact the price of the wine. We can replace it with multiple ways, Sneddon, but here we are more bothered as to using this in a very simple sense. Okay, you can replace with mean, median, mode. There are multiple ways, but those are all advanced techniques, and we don't want to fit in all of them right now in this 1 hour session. So let's kind of keep it easy and simple. Okay, so we are going to do all the features of input features of the wine, and we are going to try to predict the price of the wine. And this is the pattern that I want the machines to learn. So let's see how I could have made the machines learn. And friend, till now we have not even seen the machine learning code. It's going to come up in a while. As a data scientist, we also do a certain visualizations to understand your data much better. So we take it in a very scientific step-by-step process to understand your data better. And once you're convinced with the data, you know that the data is good, and you know that obviously machines are not smart enough, but I have my data which is good. So I will force the machines to now find patterns within a good data. If I were to pass bad data, machines would have figured out a bad pattern. But now, since my data is good, I believe the machine is going to find good patterns. So now, friends, you will be surprised to see how big a code is for machine learning. So till now, we have not even done machine learning. It was only about understanding the data. Now we'll split the data into two parts. These are the input features of the wine, and the output feature is the price. So we're going to find patterns between the input features of the wine to the price. Similarly, for test, we are going to take only the input values, and we're going to hide the output value. Okay, this is the output value, which is the price. We're going to first predict the price on this X test, which is the input values. Then we're going to compare it with the answer key, which is the Y test. Okay, so you see here the price has been removed from the input values when we are going to ask for the test questions. So friends, technically, machine learning is hardly these 4 lines of code. Okay, it's just hardly these 4 lines of code. And more or less, you'll find this pattern true for almost every kind of machine learning that you're going to do. Few things are going to change here and there, but mostly machine learning is fixated to these 4 ideas. The first idea is you load somebody else's hard work. Somebody else knows how to write a linear regression better than me. So I'll just use that person's code. I will pass my data, my input and output of the data. Input was all the features of the wine. Output was the price. So I'm interested in finding the features to the price relationship. Okay, this line is the most important line, where the machine is trying to train itself to learn patterns between input and output. Once this is achieved, you are going to test it. Okay, you have trained your machine. This one line is basically for training your machine. After that, you're going to test your machine. Is the machine able to predict properly? So you're going to take a test. Once it tests, once you have tested, what do you want to do? You want to find the score. How good was the machine in predicting? So you see here, the original value was 6.95, and this model, it predicted 6.82. For the second wine, it was 6.49, but this machine learning model predicted 6.75. So you understand, with only 25 rows of data, I could actually get so close to the actual prices, 13 cents and 25 cents here and there. Okay, do you all understand? This was 13 cents less. I predicted 13 cents less for the first wine and 25 cents more for the second wine. With just 25 rows of data, I was able to get so close. What do you think would have happened if I had, say, millions of rows of data? Suppose I had millions of rows of data. Don't you think your machines would have been a little more scientific in that case? Wouldn't they be a little more better? Yeah. So yeah, absolutely. The more information, the more variety that your machine sees, your machines will be more smarter at prediction. Absolutely. Finally, once you have seen this, you got to evaluate, right? So how close is my model to real world? And there's a concept of mean squared errors. So we try to find the error. It's very similar, like you have 100 marks exam and you scored 98. So what is your error, friends? Your error is 2. So we are going to try to find out all the errors for all the possible values and see how close is my data to the real value. So error, lesser the error, better the model, or more the error, better the model. That's pretty obvious, right? Lesser the error, the better the model. So now we have we have figured out a pretty nice value, which is 0.2, which is basically 20 cents. So this model by itself overall is having a 20 cents error. Okay, 20 cents error overall. Now, how does this thing really help me? In future, I'll actually create more models and see if any model is better than this one. Now, models could mean a simple equation. Okay, in the first one, what was the equation? How was price related to the other input values? We had 1, 2, 3, 4, 5, 6. We had 6 input values. These 6 input values to the output value was my equation. I was trying to find the equation of price, which can be deduced by finding the equation of these 6 values. Okay. What I do is, I was not very convinced about France population, so I dropped France population and tried to make one more one more model. So you see here, in the second case, I removed France population. And I'm going to see if this one is better than my first case. So what I did, I repeated the same idea again. I again figured out the data without the France population. I tried to make the model learn again without France population. And this time I also calculated what was the error. And surprisingly, this time the errors are actually much less. It is 0.818, which is 18 cents. The previous one was 20 cents. This is 18 cents. So you see the model is actually better. And how is it better? If you see here, the prices are 6.77 and 6.68. So if you see here, the new difference is 18 cents less for the first one and 18 cents more for the second one. As opposed to the previous model, I had 13 cents less for the first one and 25 cents more for the second one. So here, if you see, I'm much more closer to the actual values as opposed to the first case. Obviously, this is a little more than the first case, but still, overall, my machine is much better. Okay, so this is a simple idea how you can actually execute machine learning in real world. With so low amount of data, I could come so close. So think when you have massive amounts of data, I just had 25 rows of data here, friends. Just 25 rows of data. In 25 rows, if I could have come so close, think what is the possibility you could have achieved when you had millions of rows of data. Okay, so does that make sense to all of you? Everybody is with me on this point that if we had a little more information, I could have got even further closer. Either way, it is pretty close, 18 cents and 20 cents here and there, but still, you see how machines can be smart in predicting the price with respect to the other parameters. Okay. And that's why machines are so powerful. Okay. Why are plots required, Amit? These plots are for analysis. So when you are a data scientist and you're trying to do machine learning, you need to understand your data better than others. So to understand the data better than others, what do? You apply machine learning. Okay. But to apply the data on the machines, you need to be sure if the data is good or bad. These plots help you understand if the data is good or bad. Okay, this plot is called as box plot. The next one is violin plot. This is called as heat map. So these are all standard stuffs. And these are things that you learn once you get into data science. But very important that all of you realize that machine learning in the real world is a very small amount. Machine learning is a very small amount of work that you do as an individual or as a scientist. Can anybody tell me why? Why do you think machine learning is not my major task when I am a data scientist? Why do you think machine learning is not my major task as a scientist, as a data scientist? Because it's the same idea that I told you. If there's a Maruti 800 where by mistake there are 2 extra zeros, what will happen to the machine? The machine will think, okay, this is some XYZ car which is priced at 2 crores. Okay, so the machine has no idea Maruti 800 is not worth 2 crores. So you as an individual, as human, has to understand your data better and solve it. So 60 to 80% of a data scientist time goes in not only data analysis part, but also data cleaning, data restoration, data ensuring that data is, it is totally gold, worth gold. We call it as gold in, gold out, GIGO. So if you're putting in gold into the machines, the machine will give you out gold. But if you put in garbage to the machine, all that the machine will do is garbage. That's it. To great extent, I would say yes. You can also term it as domain expertise. Now, obviously, as you saw that in today's session, we actually walked through a little idea about what is data science, and especially in terms of machine learning, how does it fit into the picture? This in itself requires all of us to study at a great extent what exactly is data science all about. And to understand data science, it's not an easy game. It's not a straight cakewalk. So we as individuals need to learn machine learning and data science. But the path to data science is actually a little difficult if you don't have the right